This is a video on differentiation with an emphasis on the chain rule. But first, we want to look at the derivatives of some essential functions. On number one, the derivative of x to the n with respect to x is nx to the n minus 1. Number two, the derivative of e to the x with respect to x is equal to e to the x. Number three, the derivative of natural log of x with respect to x is equal to 1 over x. Number four, the derivative of sine of x with respect to x is equal to cosine of x. Number five, the derivative of cosine x with respect to x is equal to negative sine of x. Number six, the derivative of tangent x with respect to x is equal to secant squared of x. Number seven, the derivative of secant x with respect to x is equal to secant x times tangent x. Number eight, the derivative of cotangent x with respect to x is equal to negative cosecant squared of x. Number nine, the derivative of cosecant x with respect to x is equal to negative cosecant x times cotangent x. And number 10, the derivative of b to the x with respect to x is equal to b to the x natural log of b. In that one, b is a real number, b is greater than 0, and b can't be 1. Okay, so for example, b can be 5, right? So in other words, the derivative of 5 to the x with respect to x is equal to 5 to the x multiplied by natural log of 5. Now, with that, I want to start looking at the chain rule. Recall, the derivative of sine of x with respect to x is equal to cosine of x. Suppose f is a differentiable function, all right? And what we're going to do is we're going to look at the derivative of sine of f of x with respect to x. The inside function is f of x. The outside function, if you will, is sine of x. So we're going to take the derivative of the outside function and evaluate it at the inside function. So in other words, we get cosine of f of x, like so. But I'm going to take that answer and multiply by the derivative of that inside function, which in this case is f prime of x. And that's the chain rule for a specific looking function. Now watch this. Let's take a look at an example. Suppose I had y is equal to sine of x cubed. My inside function is x cubed. And so if you don't mind, I'm going to let that be f of x. So f of x is equal to x cubed. The derivative of that inside function by the power rule is 3x squared. So when I look at dy dx or y prime, I get the derivative of the outside function, which is cosine of x cubed. So I'm evaluating the cosine at x cubed. So I get cosine of x cubed. And I multiply by the derivative of the inside function, which is 3x squared. And then if I rewrite this, I get 3x squared cosine of x cubed. Example 2. suppose y equals sine of cosine of x. Now, in this case, f of x is equal to cosine of x. If I take the derivative of that inside function, I get negative sine of x. So dy dx is equal to, the derivative of this outside function here is cosine of, and I'm going to evaluate that at the inside function. So it's cosine of x. And I'm going to take that answer and multiply by the derivative of that inside function, which is negative sine of x. So if I rewrite this slightly, I get the following. dy dx is negative sine x times, and then if you look over here, it's cosine of cosine x. You're done. And then let's do one more example here. So let's take a look at example 3. Suppose y is sine of e to the x plus x cubed plus, it really doesn't matter. We can say natural log of x and just exaggerate it. Okay, so now I got the sum of 3 differentiable functions inside sine, which is itself differentiable. So here, we'll do it this way again. Now, note, f of x is equal to e to the x plus x cubed plus natural log of x. That's the inside function. If I take its derivative, right, I get e to the x plus 3x squared plus 1 over x. So when I look at dy dx, I get cosine of f of x, right? In other words, I get cosine of that inside function. And the inside function is e to the x, right, plus x cubed plus natural log of x. And I'm going to take that answer, right, and I'm going to multiply by the derivative of that inside function. So I'm multiplying by the derivative of e to the x plus x cubed plus natural log of x. And when I do that, I get e to the x plus 3x squared plus 1 over x. And I would just rewrite it this way. Therefore, dy dx, right, is equal to e to the x plus 3x squared plus 1 over x, and I'm going to take that quantity times cosine of e to the x plus x cubed plus natural log of x. And you can exaggerate it to make it however you like, right? That inside function, as long as it's differentiable, we should be able to do this. Okay. Now, recall, the derivative of, we'll do a different function. So we'll do b to the x. The derivative of b to the x with respect to x is equal to b to the x times natural log of b. Okay, this one's tricky, all right? Now, if I take the derivative of b to the f of x with respect to x, and we're assuming f is differentiable, so we're going to follow the same blueprint, right? In other words, we're going to write b to the f of x times natural log of b. But I have to take that answer and multiply by the derivative of f of x. And the derivative of f of x with respect to x, by the way, is f prime of x. So your formula will look like this. Now, let's take a look at some examples of that. Suppose y is equal to 3 to the x squared. And I want dy dx. Now, my f of x is the exponent on that 3, which is x squared. The derivative of f is 2x. Okay? So when I write dy dx, I get 3 to the x squared times natural log of 3, right? But I'm going to take that answer and then I'm going to multiply by the derivative of x squared with respect to x, which is equal to 2x. And I'm done. So I'm just going to rewrite it this way. So I get 2x times natural log of 3 times 3 raised to the x squared. Now, let's take a look at another one. Suppose y equals 3 to the sine x. Now, in this case, my function, my inside function, is sine of x. The derivative is equal to cosine of x. So y prime, or dy dx, is 3 to the sine x times natural log of 3, right? But remember, I have to take that answer and multiply by the derivative of sine x, which is equal to cosine of x. Now, if I just rewrite this slightly, I get natural log of 3 times cosine of x, and I'm going to take that answer times 3 to the sine x. That's how the chain rule works. And let's do one more example for this video. So we'll call this example 3. Suppose y equals, we'll say 4 to the 2x squared plus sine of x. So we can add two functions for that exponent. That's fine. Now in this case, f of x is equal to 2x squared plus sine of x. F prime of x is 4x plus cosine of x. So dy dx is equal to 4 raised to the f of x, which is 2x squared plus sine of x. And I'm going to take that answer times natural log of 4. And then I'm going to take that, I shouldn't say answer, but I'm going to take that and multiply by 4x plus cosine of x. And I'm done. And so here I get natural log of 4 times 4x plus cosine of x times 4 to the 2x squared plus sine of x. just to let you know, that was my child. He came in, and yeah, so I apologize in advance for that. But I don't want to redo this video, so I'm going to leave it as is. One last thing I'd like to go over. Now, I want to reason out the derivative here of b to the x. So this is equal to e to the natural log of b to the x, okay? And this is equal to e to the x times natural log of b. So it's just properties of logs. Now, recall, the derivative of e to the f of x with respect to x is e to the f of x times f prime of x. So the derivative, we'll say therefore, the derivative of e to the x times natural log of b with respect to x is equal to, I'm going to get e to the x times natural log of b, and I'm going to take that answer times the derivative of x times natural log of b. So remember, natural log of b is like a number. It's like 5, okay? The derivative of x with respect to x is 1. And so this is equal to e to the x times natural log of b times natural log of b. Okay? But remember, e to the x times natural log of b is equal to b to the x. And so this is equal to b to the x times natural log of b. And so if we put this together, the derivative of b to the x with respect to x is equal to b to the x times natural log of b. And that'll conclude this video. It's a video on derivatives with an emphasis on the chain rule. So, okay, thank you.